Alright, so here's some examples from 4.2. So let's say a material has a half-life of 1 year and we begin with 100 kilograms. We want to know how much will remain after 5 years. So since this is a continuous formula, we're going to be using the PERT formula. So we're going to have 100, the initial amount, times e to the negative 0.5 times 5. That's going to give us about 8.208, whoops, 5. Now, this is because it's decaying, or decays continuously. Now, if it didn't decay continuously, here's what we would expect. We would expect to start with 100, and then have 50, 25, 12.5, which we'll just say is 12, and then about 6. Now, because it's decaying continuously, we're actually going to have a little bit more than that. That is why we end up with the 8.2085. Okay, so remember, if something's doing something continuously, that's when you're going to use the PERT formula. Otherwise, if it has a clear compound, you're going to use the compound formula. Now, for the next formula, or for the next example, we are going to look at a cheetah population, which can be modeled by A of t equals 1400 divided by 1 plus 13e to the negative 0.02 t. And we want to know what's the initial population. So we're going to plug 0 in for this guy. Then we're going to evaluate the formula. So when we plug that in and we do the math, we're going to end up with 1400 divided by 14, which is going to give us the initial cheetah population's 100. Now, here's the reason why, is that's actually going to be e to the 0, which anything to the 0 power is 1. That's why we end up with 1 plus 13 times 1. Okay, great. Now the next thing we want to do is we want to ask, what will the population be, or what is the population after, let's say, 20 years. So we're going to plug 20 into this formula, and we're also going to round this, so we're not going to have any like half or quarters of cheetahs. Oh, and that was my mistake. I should have put a 13 in front of the e, but you should still get the same answer. You're going to get 1131. Now when you plug this into your calculator, here's how you're going to plug it in. Again, I forgot to put the 13 on here, I'm sorry. Make sure that you put that exponent in parentheses as well as the entire denominator in parentheses so that your calculator knows that you're grouping it together. Alright, now last but not least, for C, we want to know what the population will reach as t goes to infinity. So as we look at the cheetah population forever and ever and ever, does it ever actually like taper off, or does it shoot down? So you can test this by putting in large values of t. Or if we're putting large values in for t. And what you're going to see is that the number is going to get really close to 1400. Now, if you don't want to continue to put in bigger and bigger numbers in for t, here's another way you can think about it. You don't have to, you can just play that numbers game. But here's why theoretically it equals 1400. So we have 1400 divided by 1 plus 13 times e to the negative 0.2t. Okay, now here's the deal, is that if we just look at this piece right here, because e is to a negative exponent, we can rewrite that e as being in the denominator. That's one of our exponential rules that we saw the other day. Now, as t gets bigger and bigger and bigger, what happens is that this whole fraction is going to go to 0. The reason is, if you take 13 and keep dividing it by bigger and bigger and bigger and bigger numbers, it's eventually going to get very, very small, or go towards 0. So, if that fraction goes towards 0, then this is going to turn into 1400 divided by 1 plus just 0, which is how we get 1400.